Here we go. I'm gonna have to. Number one. All right. I did video yesterday, but I had some problems getting all the videos up. It was processing forever. They're all up, and I have them. So if you're gone yesterday, we did a lot of the legwork to get to this point. Anyways, find the open intervals on which the function is increasing and decreasing. So here's what you're going to be doing on your assignment. Number one. F of x equals 8x minus x cubed. All right, what is the first step that we went through yesterday to find intervals of increasing and decreasing? Find the CVs. Step one is going to be find CVs. Okay, step one, find CVs. And that specifically is where the derivative equals 0 or what? Undefined. Now, this is a polynomial, so will the derivative be undefined? No, because polynomial is continuous everywhere and differentiable. So we're not going to have to worry about looking for its undefined. The derivative is going to be 8 minus 3x squared. 8 minus 3x squared. All right, any questions there? All right, now we set it equal to what? 0. You don't have to worry about it being undefined. Okay, I'm going to write it every time, but I'm going to cross that out because it is a polynomial. So all I'm going to have to worry about is 8 minus 3x squared is equal to 0. All right, solve for it. I'm going to move the 8 over. Actually, I moved the 3x squared over. So we're going to have 8 equals 3x squared. Divide by 3. We're going to have 8 thirds is equal to x squared. So we're going to have x is equal to plus or minus root 8 thirds. You do not have to worry about doing anything with that. You can just leave it that. If you do want to simplify it, it would be goofy. All right. Now, next step. What's step 2? Okay. Be with me today. This is all the big stuff to get you ready for the big assignment. What's step 2? Sign analysis. It's your essay. Sign analysis for F prime. I abbreviate sign analysis SA. Okay. Is everybody okay with that? Yeah. All right. Where's Teo at? Huh? That's a good question. That is good. Oh, no, they're all knowledgeable. That's right. So SA. All right, sign analysis. We're going to use our critical values. This divides up the x-axis. This is where your graph can go from your derivative, okay? Because where the derivative equals 0, think about it, this is the derivative. We set the derivative equal to 0. This is where the derivative crosses the x-axis. So this is where your derivative goes from above to what? Below, or from below to what? Above. Where it's above, it's where it's positive. Where it's below, it's where it's negative, which tells you where the original function is increasing and decreasing. The derivative tells you where the original function is increasing and decreasing. Just like we use velocity for position, and it told me where it was going right or left. Okay, same thing. All right, so it's going to be negative infinity to negative root 8 thirds. You don't even have to know what negative root 8 thirds is, Blake. Okay? You do need to have all this work. This is going to be big points. And then we're going to go to positive 8 root 8 thirds. Now, it does not mean I'm going to not make you turn this homework in. I just haven't you turn it in yet. Okay, so make sure you have all this down. All right, we do our sign analysis. This is going to be our F prime line. I'm going to determine if F prime is above or below the x-axis by figuring out if it's positive or negative, which will tell me where F is increasing or decreasing. So, test value. What would you test? 0 is easy to test. 0 is going to make this what? Let's see, it'll be 8 minus 0, which is a what? Positive. Signs will alternate because there's no multiplicity that's even. Then what this does is it tells me what F is doing. F prime tells you what's happening on the F. It tells me that it's what? Decreasing, increasing, and decreasing. Now, in this homework, I'm going to let you just cheat with the sign analysis. But on your big assignment, you have to actually what? Write it out. You have to write it out. So let me write it out once, just for those of you who were gone yesterday. I think 1 or 2 of you were gone yesterday, so let me write it out. So you would have to say F is increasing on your big assignment, okay, which we're going to go over. You would say F is increasing from negative root 8 thirds to root 8 thirds because F prime is what? Positive. And then you say F is decreasing from what? Negative infinity to negative root 8 thirds. And they're always open intervals. Remember we said that yesterday in the notes. Union root 8 thirds to what? because f prime is what? F prime is negative. That's what you actually have to write on your big assignment.
Couldn't you just say everywhere else instead of writing that like?
Nope.
Oh, dang.
Okay. Number 2, I'm getting excited about this one. Tomorrow I'm doing my morning session. I'm going to go back through some of the EVT problems, and I'm going to be going over another one of these tomorrow in the EVT. Tomorrow, if you come in the early morning session, I'm going to be just basically cleaning up whatever I didn't finish today to be able to start the assignment tomorrow to jump into it. The 7:30 session, the extra credit stuff, which I already have a note card started. And I did put extra credit in last try. This try, though, okay, this is the try where I allow the extra credit when we start doing 7 a.m. sessions. That one gets to go in for quiz grades.
7 a.m.?
Mm-hmm. Mm-hmm.
Let's just go ahead.
Yep. Oh, no. Sorry. Did I do 7:15 or 7 a.m. when I did the really early one? 7:15 because I can go to 8 because we have the champion time. But when I do the 7:15s, that's going to be extra credit to go into your quiz grades. Okay? So that'll actually go into quiz grades.
Mars, I have a question. If we get like a passing grade on
No. But I do, hey, she asked a good question. If you get, first of all, the class is over. I don't get the score to July. So if you get a passing score on the AP exam, I don't go back and change your grade to an A. But by taking the AP exam, I don't do a final, and everybody gets 100% on the final. And I actually plug in 100% for the final. So.
Wait, how much of that is my grade?
I guess you're taking this over again in college. Okay?
Well, I have all that work.
Where do you go? Where are you going?
St. John's.
No, you don't. Not if you get a 4.
Not if you get a 4.
Yeah, you need a 4. Okay? We can do it.
Yeah, we can do it.
Okay? All right, here we go. Shh. And by taking the AP exam, if you show them your AP score, because St. John's, a lot of the private schools make you take a college placement test, it does exempt you from that college placement test.
Oh, it does.
Yeah, 100%. All right, here we go. Number two. Shh. We're not going to be cranking out super early. I'm just going to do Wednesday, Fridays for right now, the 7:30 stuff. It's when we get to April that I start saying, we got to get ready for this exam. Okay? We did 7 a.m. 4 days a week for 4 weeks straight. And I had one kid that made every one.
Hey,
And he made a 5.
we can do this, guys. Guys, we can do this. Every single one of us shows
No,
up that day.
we did 7 a.m.s.
Cash, I'll pick you up.
Yeah, so I'm going to do 7:15. Give a little spare.
You're not waking up that early, buddy.
Not for the extra credit. Here we go. Number 2. Just remember, I got to come to every one.
Marcy, you should change your first hour to study for Cuck.
Yeah. Kick out
Change your first hour, kick out college
What's your
algebra.
prep hour?
Maybe. Here we go. G prime of x. We need to do the derivative. All right. I gave you a hint. I want to see if anybody was able to get this. This is the hardest derivative to do on the AP exam. This is the hardest derivative to do on the AP exam. Okay? Ready? Because this one requires product with a chain. All right? So it's going to be the derivative. The first is what? 1 times 9 minus x squared to the what power? 1/2 power plus x times. Now this next part is going to be 1/2 times 9 minus x squared to the negative 1/2 times a negative 2x. That required chain rule. Now, I do think it helps. I think Hunter, it would be beneficial for Hunter to clean this up a little bit first before he actually writes the final answer. So I'm going to clean it up. So I'm going to go G prime, before I factor, I mean. So do you need this 1, first of all?
No.
All right, so I think it'll just make it easier for you to see what the next step is. Some of you don't need to do this. You can see what the next step is. I've got this. This is all multiplied together, so we can combine stuff. We can cancel multiplication. We can bring a negative out front. We can cancel the 2's, can we not? We can bring that negative all the way out front, and we can break that x times x. So it's actually going to end up being negative x squared out front. Do you see that?
I can.
All right. Now I think it's really easy for Mari to see what we're going to do next, which is factor. I did this in the Algebra Gateways first trimester. You got to look at this and say, what do they have in common?
Negative 1/2.
The 9 minus x squared. And we're going to take out the least power, the one with the smallest exponent. So I'm going to take a 9 minus x squared out of this. I'm going to factor it out. And I'm going to factor out the least power. That's going to leave me with whatever's going to be left after I divide each one of these by that. So I'm going to take this divided by this and this divided by this. Both of them are going to get divided by that whole quantity. Now, if I take this first one, it's this divided by this. They're the same, but their exponents are different. So what do you do with the exponents? Subtract them. What's 1/2 minus a negative 1/2? It'll be 1. So it'll just end up being 9 minus x squared to the first power. Everybody see how I got that? Now, this next part over here, what do you get when you divide this? Notice they're exactly the same. So what's going to happen when you subtract the exponents? You get an exponent of 0, and anything to the 0 power is what? So it basically cancels. The second part cancels, so we get a plus x squared. So I shouldn't have had that cancel there. Oh, it is minus. There's a minus, sorry. So it'll be a minus x squared. This will cancel. Okay? Good. So then we're going to get, bring this to the denominator. So we're going to have 9 minus 2x squared on top over 9 minus x squared to the 1/2 power on bottom. Now we do have a derivative where it will be equal to 0 or undefined. Where does a derivative equal 0? When the top equals 0. So top equals 0. Okay, so that'll be the 9 minus 2x squared equal to 0. When does the derivative undefined? When the bottom equals 0. So that'll be the 9 minus x squared to the 1/2 equals 0. But do you really need the 1/2 power?
No.
You can just square both sides and get rid of that. So I'm going to drop the 1/2 power. Okay, so I'm going to solve both of these. So let's solve this one over here first. The 9 minus 2. So I can have 9 equals 2x squared. So we're going to have 9 halves is equal to x squared. So we're going to have plus or minus root 9 halves. That's not multiplicity 2. That's two different answers. That's root 9 halves, and that's negative root 9 halves. That's two different answers. You could have 3 over root 2 if you want. You don't have to, though. They don't care about simplifying roots at all. The only time I really ever simplify roots is when I'm doing trig.
They don't do these problems on the multiple choice, just the free response.
No, there'll definitely be some ones on the multiple choice.
But then,
And they'll probably have root 9 halves. Yeah, they'll probably have root 9 halves in the multiple choice answer. You'll know. You'll look at the multiple choice answer and be like, oh, they got 3 over root 2. They took the square root of 9. Okay. This right here is going to give me 9 is equal to x squared, which is going to give me x equals plus or minus 3. So I got a lot of critical values here going on. So sign analysis is going to be a little whack. But I told you yesterday, this is going to burn you if you don't do this. You got to check the domain because you might throw some of these critical values out. So how do you check the domain? You look in the original problem and you say, what can x not be? Well, x cannot be something that would make this what underneath the square root? Negative. You don't want it to be negative. You want it to be greater than or equal to what? So we're going to check the domain there. So we're going to have to take 9 minus x squared and make sure it's greater than or equal to 0. So you're going to have to do a sign analysis just for that, which is different from the sign analysis we're going to do for increasing and decreasing. Or would you like a way to cheat the domain a little bit today? All right, I'm going to cheat it today. I just want to know where this parabola is above 0. I know that parabola is going to cross at what? 3 and negative 3. And that's a parabola opening down. Would you agree? There's your sign analysis. I want to know where it's positive. Where is it positive? So my domain's going to be from negative 3 to 3. Included. It is included because you can take the square root of 0. Agreed? That's without having to do the sign analysis. Now, some of you are like, I might have a hard time, Mr. Morris, doing that. So then you would set this equal to 0. You'd get plus or minus 3, and you'd do a sign analysis for that real quick. You would go negative infinity to negative 3, negative 3 to 3, 3 to infinity, and you would come up with the same result. You would come up with minus plus minus, which right there. And you do include the negative 3 to 3 because it can equal 0. You can take the square root of 0, right? You can't take the log of 0, but you can do the square root of 0. Logs, you just do greater than 0. Square roots, you do greater than or equal to 0. Does everybody keep that straight? That's really the only domains you got to check. And zeros in the denominator if we have a fraction. If you can keep track, listen, the only 3 domain things you need to check for. You ready? Zeros in denominator, negatives underneath square roots, and logs of negatives or 0. If you know those 3 domain areas, boom, you got it. Okay? So I'll kind of review that because that's every 20 problem, you got to check the domain. Here's the good news on your assignment. The first 12 problems are all polynomials. So what's the domain going to be? All the numbers. It's going to be pretty light. All right. So do we include all these critical values? Are you sure?
Not the negatives.
Well, no, I'm going to include plus or minus 3 is definitely in the domain. Is that agreed? Yeah. Is plus or minus root 9 halves going to be in the domain? Well, 9 halves is what? 4.5. Is the square root of 4.5 going to put you between -3 and 3? Yeah. It does. So, yes, you're going to include them all. So, guess what? Our sign analysis is really big and nasty. Here we go. It's going to be from -infinity to -3. It's going to be from -3 to root 9 halves. It's going to be from root 9 halves to what? 3. Thank you, Mr. Morris. And then it's going to be from 3 to what? Did I get them all?
What about cosine halves?
Oh, I missed it. See, I was asking you guys. You guys didn't help me. All right, here we go. I missed one. Yeah. So root 9 halves to what? Positive root 9 halves. Then what? Root 9 halves to what? And then what? All right, there's 5 intervals. Now, the good part is none of these are multiplicity 2, so the signs are going to what? Alternate. So let's test this one. Let's test that yammer, because I don't think you guys are going to be able to do end behavior on this one. So, but I can do this pretty easy. If I put a 0 on top, what's that going to make?
9.
Positive 9. So positive, right?
Yes.
If I put a 0 on bottom, what's it going to make it? Positive. What's a positive divided by positive? All right, signs will alternate. Boom, rip. All right, so that's my F prime line. So what does that tell us about F? It tells me it's increasing, decreasing, increasing, decreasing, increasing. I'm not going to write it out, though. Is that good enough for you? Yeah. Okay, good. All right, let's do a trig one and an e to the x one, and then let's go to the next part, which is find the actual extrema and then concavity. All right, this right here. Find the derivative. I'm going to go quick. What's the derivative of x plus 2 sine x? 1 plus 2 cosine x. Now, they did restrict the interval. They will always do that with trig functions. Otherwise, there's an infinite number of answers for critical values. So we're only looking for so many critical values here. Okay? And this is still not an EVT problem because they're not asking for what the absolute max and min is. But since they did give us a closed interval, would there be a max and a min? There would be an absolute max and an absolute min because this is continuous on the closed. But they're not asking for it. They just want to know where it's increasing, decreasing. All right, so critical values. So I'm going to set the derivative equal to what? Do I have to worry about where it's undefined?
No.
Cosine is never undefined. All right, so that's going to give me cosine x is equal to -1/2. Unit circle work. Here we go, Blake. Let's see how good your unit circle work is. All right, can you tell me where cosine's negative, first of all? And then I'll call on somebody else to tell me the value. Is negative in which quadrants?
No, I don't know.
3 and 4. 2 and 3.
2 and 3, because cosine's the x. If it was sine, it would be 3 and 4. Cosine's the x. You better remember that. So we're going to look for quadrant 3, or quadrant 2, and quadrant what?
3.
Now, your 5 fingers. Does anybody remember where cosine is 1/2? It's at pi over 3. So I need pi over 3s in quadrant 2 and 3. So what would it be in quadrant 2? 2 pi over 3. What is it in quadrant 3? There you go. That's your critical values. So my sign analysis is not going to be from -infinity to infinity, is it?
No.
My sign analysis is just going to be from 0 to what? So I'm just going to go from 0 to 2 pi over 3. From 2 pi over 3 to 4 pi over 3. Not that you could go from no, you can't because there's more critical values outside of this interval. So you do need to restrict the interval with what they gave you. All right. What value would you test here? Yeah, pi or pi over 3. You could do pi over 3 would be here. Pi would be here. I don't care which interval you test. I'm going to do pi. I like pi. Pi is easy to work with. Okay, pi. If I do pi, which is right here, what's cosine of pi? -1. 2 times -1 is? 1 plus a -2 is a? So the signs are going to what? So increasing, decreasing, increasing. This is your f prime, and this is what it means for f. That was pretty easy. Did you do that one right? Good job.
Is this what's on the AP exam?
Yeah, oh gosh, this is 100% on the AP exam. There's like 10 to 12 questions on multiple choice like this. They love, that's why I make this assignment so important, because there's so many of these. Not just increasing, decreasing. Concavity point, but it's the same stuff. You do sign analysis.
How many questions?
45. Yeah.
Wow, that's a high percent.
Good chunk of doing POIs or relative extreme or increasing or decreasing or concavity.
That's pretty good.
Yeah, it's pretty good. All right, here we go. Number 4. I would say the other 10 to 12 questions on another good chunk of the multiple choice is going to be integrals. All right, here we go. Derivative, f prime of x. Here we go. I'm going to have e to the negative x times a -1, so I'll put a -1 there, plus e to the 2x times a 2. All right, I'm going to set this, by the way, e to the x, J-curves and L-curves are continuous everywhere. Agreed?
I guess.
Yeah. By the way, e to the negative x, is that a J-curve or an L-curve?
That's an L curve.
Because it's a negative exponent. What's e to the 2x?
That's a
J-curve. Okay, good. So you got an L-curve plus a J-curve.
You're lucky, yeah. Right.
That's a loser, Jeff. All right, here we go.
Don't put yourself down.
I don't. I'm good. All right, set the derivative equal to what? 0. So I'm going to have negative e to the negative x plus 2 e to the 2x. What did I say to do on these e problems? Please always factor out a power of e and factor out the smallest power of e. So what's the smallest power of e? Negative x. So we're going to factor out e to the negative x. I'm going to actually factor out a -2 because I don't like the first term ever being negative. So I'm going to take a negative out too. Is that okay with you? You don't have to. If you didn't do it, it's not going to bother me. It will not bother me whatsoever. All right, that's going to give me a 1. All right, and that's going to give me a -2 e to something. Now, what's the rule when you divide powers? What do you do with the exponents? So we're going to have 2x minus a negative x. 3x, very good. Equals 0, good. I like this. We went over this yesterday, which I think my videos are finally uploaded. Let's see. Nope, one more still processing, but that's pre-calc. That doesn't matter. All right, so we're going to set each one of these equal to what? Now, what did I tell you get to do when you set this one equal to 0?
Ignore it.
Ignore it. Throw it out because it's an L curve. Can an L curve ever equal 0?
No.
Can a J curve ever equal 0? No. This won't have solutions. Okay? Now, this one gets shifted. So it's a shifty shift. I didn't say anything close to what you think I said, so I don't even know why you're woeing. All right? -2. I'm gaslighting you. You guys are gaslighting me. I think it's the reverse. So don't gaslight the gaslight, because then there's going to be an explosion. We can go back to the vid. We will run it back later. Okay?
They're not gonna let you off. YouTube's gonna take it down.
I said shiesty. All right. So I got this equal to 0. All right. So I'm going to have 1 is equal to 2 e to the 3x. This one you can't throw out because you're not actually figuring out where e to the x equals 0. You're figuring out where e to the x is going to be equal to what? 1/2. So this does have a solution because J curves and L curves can cross 1/2. And now how do you solve this? I said yesterday. No, that's if it's a log, you go full circle. If it's an exponential equation with a listen, I'm going to tell you. A log, you go full circle. Everybody say it. Log, you go what?
Full circle.
But if it's an exponential equation, which means there's a variable in the exponent, you take the log of both sides. Now, what kind of log am I going to use? ln. So I'm going to go ln of 1/2. I'm going to go ahead and tell you, I always use ln. I don't ever not use ln. I just do the ln of both sides because it doesn't matter what base you use. Okay, so ln of e to the 3x. Now, why did I use ln? Because what's going to happen to the ln of e?
It's going to cancel out.
And then you can pull that monkey out of the tree. So you're going to have ln of 1/2 is equal to 3x. Divide both sides by what? 3. So we're going to have x is equal to ln of 0.5. I don't want to write 1/2 divided by 3, just because I don't want to have a complicated looking answer. Now, one thing, by the way, number 4, was the domain all real numbers?
Yes.
So there's no critical values you have to throw out, right? So my sign analysis is going to be from negative infinity to ln of 0.5 divided by 3. And I'm going to show you how to do this without the calculator. Because some of you are like, I don't know what to test.
Oh, bless you.
Well, now you bless me. Okay? You were throwing me under the bus a minute ago. All right, ln of 0.5. Blake, I'm going to give you a little hint here. Blake needs to know this. Okay? ln graph is what kind of a curve, everybody? R curve. I like that. Okay. It's an R curve. Okay? It is definitely an R curve. Okay. Now, Blake, the domain is x greater than 0. I'm taking the natural log of 1/2. Look at this graph. If I take the natural log of something that's a fraction between 0 and 1, what kind of answers do you get? Negative answers. If you take the natural log of 1, what do you get? That's where it crosses. And then anything after 1 is going to be what kind of a value? So I know natural log of 0.5 is a negative number. So what's a negative divided by 3? A negative. So I know that this is like negative something. So I think I can test 0, and I'm confident I know where 0 is going to be. Because if I know this is a negative number, then 0 is going to be in this interval. Would you agree? I can test that one. Okay, so let's go over here. 0, what's anything to the 0 power? 1, but that's going to be a negative 1. Agreed? So that's a negative. Put 0 in here. That's anything to the 0 power is what? 1. 1 minus 2 is a what? Negative. What's a negative times a negative? There we go. Positive, negative. That's f prime. F would be decreasing. And now what? Increasing. Love it. All right, let's go back to the notes. Now we're going to finish up. Yesterday we left off saying we presented the idea with a continuous function that the sign of the derivative, page 283, the sign of the derivative changes at a point c comma f of x, as well as knowing how the sign changes is going to give us insight today on the existence of extrema. Not absolute extrema, but just relative extrema. Because to do absolute extrema, you need EVT. But we're not doing EVT problems for the next couple of days. We're not closing the interval. I'm just going to ask for relative extrema, local extrema. Okay, so using the first derivative test to determine relative extrema or local extrema. All right, let C be a critical number. Does everybody know what a critical number is now? It's where the derivative equals 0 or is. If that sun's bothering you, you can close the blinds a little bit. Okay, okay. So let C be a critical number for function f that is continuous on an open interval. So is the function, does it have to be continuous? Yeah, if you have discontinuities, you have to take those into consideration as critical values for your first derivative. And that means you might have to throw critical values out. Okay? If f is differentiable on the interval, except possibly at C, okay, so can a corner or a cusp be a relative extrema? Can a corner or a cusp be a relative extrema? Yeah. So we're going to have to include those. Then f of C can be classified as following. Are you ready? So after you do your sign analysis, we've already done the heavy lifting. Now you got to look at the sign analysis and say, what does that tell you? Well, if f prime changes from negative to positive, let me tell you what that means. If f prime was negative, what did that mean in your original function? It's going downhill. So if f prime goes from negative to positive, that means your original function goes from decreasing to what? So what did that critical value have to be? A minimum. So you could basically, if you took last night's homework, we could have done all 4 problems and we could have done relative extreme with them because we already had the work done. So when it goes from the derivative, listen, when the derivative goes from negative to positive, that means your original function went from decreasing to what? Which means if your derivative goes from negative to positive, it has to be a relative min. Likewise, on the flip side, if it changes from what? Positive to negative. So let's talk about that. If your derivative is positive, what does that mean for the original function? Going uphill. And then it changes to negative, it means it's going what? And I know it had to equal 0 there, because the only way to go from a positive number to a negative number is your derivative had to go through 0. That's why we set the derivative equal to 0. You getting this now? Okay, you making the connections? All right, so if the derivative goes from positive to negative, that means the original function went from uphill to what? Which means it had to be a relative what? We now have a way to classify. So you could have went back to the homework last night, and if you looked at this, if we went back to the homework real quick, you could have said in number 1, where we had negative root 8/3 and positive root 8/3, you could have said negative root 8/3 is a what? A min. You could have said positive root 8/3 is a what? Max. Now you're going to have to write out why. You're going to have to say f has a relative min at negative root 8/3, comma, something, because I'm going to make you plug that back in the original equation and find the point. That's why this homework assignment takes so long. Okay? And then you're going to have to say that this one's a relative what? But I'm training you because this is going to be on the free response 100%. And you've got to know how to write it. All right? And then this one, look at this one. What would you say for this one? This is a relative what? Max. What's this one? Min. What's this one? Max. What's this one? Min. Because the derivative, the maxes would be because the derivative goes from positive to what? And the mins would be because the derivative goes from what? And that's what you're going to say. All right? So let's do an example. Are we ready? Let me just summarize real quick everything we've learned about this. We'll explore how to find points of inflection in intervals where a function's concave and concave up and concave down in the next lesson. The following chart will be helpful in summarizing using correct vocabulary and justifying conditions. I'm going to try and get concavity done here in a minute because it's really the same stuff. So I'm just going to do one example and then I'm going to go straight to concavity. All right, look at it. If you have a function, look at this. It's this right here. It has a function behavior. Okay, so right here you have a parabola. You have a parabola opening what? Up, and then you have a parabola opening what?
No.
Down. Notice the second derivative is what? And because it's concave what? Up, and concave down means the second derivative is what? Now that's crazy, because now I'm going to tell you something. Because if the second derivative is positive, that means the first derivative was what? Increasing. Because just like the first derivative tells you where the original is increasing and decreasing, what does the second derivative tell you? Where the first derivative is increasing and decreasing. So if you're concave up, your second derivative is positive, that means your first derivative was increasing. Where you're concave down, your second derivative is what? Nope, your second derivative is what? Which means your first derivative was decreasing. Now, when you go to increasing and decreasing, where your original function is increasing is where your first derivative will be what? Which is what we did for homework last night. Where your original function is going downhill is where your first derivative will be what? Negative. So do you kind of make all those connections? Okay, and that the symbols are over here. So let's do an example, and then I'm going to do concavity. And then I'll tie up some loose ends in the morning, do some more practice, make sure you got it all, and then we're going to start the assignment in class tomorrow. Okay, and you're going to have 2 whole days. Okay? Definitely. Here we go. All right, given the function, I'm just right now assuming March. I'm recording every day. I hate doing it, but whatever. All right, it just takes up my whole prep hour trying to get all the videos up. And then yesterday it just screwed up. I don't know what was going on, but they're all done now. They've all processed. I don't know why it wasn't processing yesterday. It was just doing the spinning thing where it says the video's processing. All right, here we go. Given the function, f of x equals, and then I found out I did no sound on one again. And I don't know why it does that, so I'm just checking it every time now. No, I'm not redoing it. All right, are you ready? We're going to do exactly what we did for homework last night, but now we're going to say where the relative extreme are. So what's the first step? Derivative. Yay, celebrate. Okay, it's Sunday school class. Here we go. F prime of x is going to be equal to 4x cubed minus what? 16x. Ooh, I like that. That's going to be nice to set equal to 0 because it factors really nice. Yeah, we're going to actually be able to set this equal to 0. I don't have to worry about undefined. Okay, so what can you take out of this? 4x, good. What does that leave us with? X squared minus 4, I believe. And then that will factor, or you can do square roots. It's up to you. I'm going to factor it this time. We always do square roots. X minus 2x plus 2. The reason I like it factored, it's easier to do when you do your sign analysis, when you're plugging in your test value. So what do we get?
X equals 0, -2, positive 2.
Yeah, x equals 0 and plus or minus 2. There's your CVs. I'm going to label those CVs. And it's CVs for f prime. Because today we're also going to find if I get, we're going to have time. We're going to have CVs for f prime, and we're also going to have CVs for f. Do you see where this assignment's getting longer and longer for every problem? Because you're going to do this for every problem. All right, now we're going to do the sign analysis. Ready? Here we go. Negative infinity to what? Negative 2. Negative 2 to what? 0. Don't forget 0. 0 to what? 2. The biggest problem that people miss points on this big assignment is they forget a critical value. If you forget a critical value, you forget one of your intervals. If you forget one of your intervals, your whole sign analysis is done. So you got to make sure you get the critical values right. Okay? All right, this is SA for f prime. You're going to have an SA for f double prime here in a minute. So there's going to be 2 sign analysis you're going to be looking at. All right, here we go. Test value. What value? You can't test 0 this time. Test positive 1. I'm going to test that one. All right, if I test positive 1, that'll be positive, right? If I plug in a 1 here, it makes it what? What will 1 make this one? Negative. What will 1 make this one? I think I've got 1 negative, so it makes the whole thing what? Negative. Is there any multiplicity that's even? No, I don't have any redundant roots. Roots that show up twice or 3 times or 4 times. So it's going to alternate plus. For right now, we're just going to cheat. Even though I don't let you do this on my big assignment, I'm just going to let you write decreasing, increasing. I know, Blake's loving that part. Decrease, increase. And then now we'll do this, but I am going to write this out the way you would have to write it on your big assignment. So what is this one going to be at negative 2? Men, what's 0 going to be? Because the derivative goes from positive to what? This is called the first derivative test. When you're looking for increasing and decreasing and using that to determine relative extrema, that's called the first derivative test. The second derivative test is a test for concavity. And then finally, what's the last one going to be? Men. So here's what you would write. So what you would have to actually write on my big assignment is you'd write there's relative men at, ready? Here we go. There's 2 relative mens. Where are they at?
-2 and 2.
Oh, hold on. You have to give me the points now.
My goodness gracious.
Yep, this is where this gets on. So what do you have to do to get the points? Some people are always like, should I plug it into the derivative, Mr. Morse, or the original equation? I don't know. Use some common sense. If I plug it in the derivative, I'm obviously going to get what again? If I plug it in the derivative, come on, tell me what you're going to get. 0, because this is where you set it equal to 0. So why would you plug it in the derivative? You plug it into the OG. You're always, to get the points, you plug it in the what? Because if you plug it in the derivative, you're going to get 0. Because that's where you set it equal to 0. So don't do that. All right. I'm not going to do the work. So you guys tell me, what are you going to get? The good news is, we'll let you cheat to save time right now. Okay? The good news is, and I'll even let you do it on my big assignment. If you got the calculator and you want to plug it in, that's fine. But the good news is, it doesn't matter. -2 and 2 are going to give you the same thing. Because it's to the 4th power and 2nd power. So it's going to end up being positive. So give me one of them and we'll get both of them. What is it? Yes, it is -15. I had to check you.
Maybe just believe your students next time.
Okay? Now, we're not even done. Because you have to say why. You're going to say because. Thank you.
I couldn't find the grapefruit, so I just got you.
Yeah, you're good.
I just got you the box of those because I couldn't find one.
You're good. Oh, I love those. You're amazing. Oh, that's so good. You just made my day. Okay, because, here's what you got to do. You got to say because f prime, my stomach's been bothering me all day, so I needed something. Because f prime changes from what? You got to say it correctly. From what? What is it when it's a relative end? Negative to what? To positive. Now, Cole might ask me this, and some people do this. I don't teach it this way. But every now and then I'll get a kid that says, can I just say because it changes from decrease to increase? You can if you use the right function. What's changing from decrease to increase? F. So if you do that, you got to say F. I don't ever do it that way because I always forget to say F. Yeah, and people just F it up. But anyway, so just don't do it that way. I would do the F prime. That's the way they do it on the answer key for the AP exam. They say F prime. Yeah, a little PG-13 there. That's the closest you'll ever hear me to cussing. All right. Run the tape back. Relative max at, what's the relative max going to be? 0 what? I don't know. I got to plug it into the original. Yep, it is 1. That one's easy. Okay. 1 because F prime changes from what? Oh, no. From positive to what? If you say increasing to decreasing, you would have had to say F. I just said. Okay. All right. We're skipping this. Yep, skipping all that for now. Go to the next section. I've already taught you about concavity. I hope this helps. Okay, I've already taught you about concavity. Concavity, I said, is when it's concave down, when it's curved what? Ritz. It's concave what? Concave down will actually produce a max. And there's something to be said about that. We're going to get to that later. But concave down is when it's curved down. Concave up is when it's curved what? Up. Like cup your hand. Everybody show me curved up. If it holds water. Okay? Holds water. No, I don't. Sorry. All right. Curved up. Show me curved down. Oh. I can't talk. In our last lesson, all right. Good for you. Be quiet now. All right. In our last lessons, we found intervals. You need to listen. This is where it gets, like, you feel like you're multitasking big time here. In the last lesson, we found intervals where the function was increasing and decreasing by discovering how the first derivative describes the direction of the function. Where the first derivative is positive, it's going up. Where the first derivative is negative, it's where it's going down. In this lesson, we'll see that the first derivative, we'll see that the derivative of the first derivative, that is the second derivative, will describe concavity of the original function. Concavity tells us the direction of the curve, how it bends. Bend to up or bent down. Just like direction, concavity of a curve can change too. Circle this, where concavity changes are called inflection points. I'm going to let you abbreviate them. P-O-I. Point of inflection. All right, we did talk about it yesterday. Now, remember when we say it's curved up, where do the tangent lines lie? Below. Remember that? That's when we did that over-underestimate thing. When it's curved down, where do the tangent lines lie? Above. Cool. Okay. Not that I really care about that right now. All right. This goes pretty quick. We're going to be right into the example because you already know how to do this. You're going to do the same thing you did for the first derivative, but we're going to do it for the second derivative now. But let's make sure we understand what it's telling you. Concavity definition. Let f be differentiable in the open interval containing I. The graph of f is concave up on that interval if f prime is increasing. Now, I want to know what that means. If f prime is increasing, what does that mean about your second derivative? Positive. F double prime is positive. Write that down. F double prime is greater than 0. It's positive. So where your second derivative is positive, the second derivative will be positive, tells you where the original's concave up, but it tells you where the first derivative's what? Increasing. It's telling you two things. The second derivative positive tells you where the first derivative is increasing and tells you where the original is concave up. So 2 derivatives away tells you what? Concavity. 1 derivative away tells you what? Increasing and decreasing. I'm going to say it again. 2 derivatives away tells you what? 1 derivative away? So if I'm at the 5th derivative, what would tell me increasing and decreasing for the 5th derivative? The 5th derivative, I'm at the 5th derivative. Where would the 5th derivative be increasing and decreasing? The 6th derivative will tell me. Where would the 5th derivative be concave up and concave down? The 7th derivative will tell me. 2 derivatives down tells you concavity. 1 derivative down tells you increasing, decreasing. So, concave up, where the first derivative is increasing, which is where the second derivative is positive. Hold on. Concave down on I is where f prime is decreasing, which is where the second derivative is what? Negative. There we go. Now test for concavity. They summarize this down here. If the second derivative is greater than 0, we know f is concave up. If the second derivative is less than 0, we know f is concave down. So now we're doing the test for concavity. Now, this is not called the second derivative test. Actually, what Kate alluded to is the second derivative test, which is if you know it's concave down, there has to be a relative what somewhere? Max. And if it's concave up, there has to be a relative. I'm going to cover that on Friday because that's a little bit different. Okay? All right, here we go. Example 1. I'm going to try and do 2. I don't know if I'll get. I'm probably only going to get 1. All right, here we go. We're just going to skip the increasing and decreasing and go right to, all I want to know is where it's concave up and down. So concave up and down, how many derivatives do you got to go down? You got to go down through derivatives. I'll race you there. I'm going to actually rewrite the original function to give you a head start. You know it. All right, f prime of x is going to be x squared minus 1. F double prime of x is going to be what? 2x. There's your second derivative. That's all I need. Now, you're going to find the CVs for the second derivative. So CVs for the second derivative.
I don't think there is any.
Oh, there is. All right, we can set 2x equal to what? So set second derivative equal to 0 or undefined. There is nowhere where it's going to be undefined. It's only going to equal 0. Where does it equal 0? At 0. So now we're going to do, so our CVs for the first derivative is x equals 0. Now we're going to do our SA for the second derivative. So what's the intervals?
0.
Negative infinity to what? 0, and then 0 to what? Test the second derivative now. Now, the second derivative tells you a lot of stuff. Let's go to the second derivative. You're testing the second derivative. All right, a negative is going to make it negative, so it's going to be negative what? Now, here's what all this tells you. It tells you a lot. It tells me where the first derivative was decreasing and what? But I don't care about that. But that's by definition what concavity is. It's where the first derivative was increasing and decreasing. But what does it tell me about the original? If the second derivative is negative, it's what? It's concave up. Where the second derivative is positive is where it's concave. Sorry, I got that backwards. Why did I write that way? Did I say it right?
No, you said it wrong.
Okay, sorry. Where the second derivative is, I can run the tape back. Okay, where the second derivative is I do think I said it wrong. Where the second derivative is negative is where it's concave down. I was just testing y'all. Okay, and where the second derivative is positive is where it's concave what? Up. Now, POI. Let's go right to it. POI only happens if it switches. Does it switch?
Yes.
So there is a POI at what? At 0 what? Oh, you're going to have to plug into the OG. Where's the OG? Oh, guess what? When I plug into the OG, it's still what?
0.
So POI at 0, 0, and then this is what you would have to say. Because F double prime You don't even have to say it goes from negative to positive, positive to negative. You just need to say it changes what? Changes signs. Oh, if you say concavity, you have to say F. I don't do it that way. I say F double prime changes signs. But if you did say changes concavity, you would have to say F changes concavity. If F double prime is positive, it's concave up. Here's your homework. Baloney. Go to page. Page 5.4. Page 5.4. Page 5.4. I'm going to have you do 1 through 10. Page 299 and 300, 1 through 10. 10 problems. You do not have to do increasing, decreasing. You just need to go down to the second derivative, do concavity and POIs. But the first 4, they don't even want the POIs. You just want to do concavity. 10 problems. And then that's what I'm going over tomorrow morning.